about this. Okay, we started recording now. There is a lot of other packages, and I must admit, I actually was not even able to delve into all of them. I'm using R, maybe people prefer Python, so they might be interested in other variants, but it's great that we have all these tools now available, so you can just go to this page and find out what is the best thing for you. Also, one very popular tool I would like to emphasize is the Pure footprint model, where you can actually go even online to this webpage here and estimate the footprint for your data, for your measurements. Other than this, there are also other types of computations you might want to do. This is then quite dependent on the application and the research question that you want to pursue with your eddy covariance tower. One of the most popular packages, I would say, gives you a lot of additional computed variables is ECN package. Then there are other also great packages that are focused on different tasks. You can just explore on your own. So coming back to the presentation once more, we were looking at the data processing chain. There is this raw, processed, quality control, get built, and summarize data. I would like to speak in more detail about openeddy software, what kind of role it actually has in this quality control, in this processing scheme. So it's actually infrastructure for data processing. So it basically gives you the tools to make some things more easier. For example, if you work with data frames having timestamp, you want this timestamp to be regular and not having any gaps. So it's good not to have to check it on your own, but having automated tools. So there is a lot of these detailed functions that are doing this in automatic way for you. The main focus is quality control. It just allows you to create your own workflows. So basically, if you want to adapt the processing, you can always change the steps of the processing to make the best workflow for your data to adapt it to your site conditions. If you would be interested in looking into isolated examples of the functions, you can check out openeddy tutorials. Here is not the full link, but if you go to the Slack, you can see it's on the same GitHub as you can see below. So there is this GitHub under my name. You can find the package openeddy. You can find workflows, which is basically the processing scheme that we are applying within our institute for our data. And you can also find the tutorials. So coming a little bit more detailed into quality assessment and the control process, I would like to emphasize that always when you are sampling, the main thing is not quality control, but it's quality assessment. So it's always important to develop within your institute some kind of measures how to check data before actually there is an issue that is taking longer time, and you never can come back in time and redo the measurements. Unfortunately, if you have a big gap in your data, it's not possible to just amend this using quality control.
Just some poor network. Sorry.
Okay. So for the quality assessment, we don't have tools here because this is basically the tedious job of checking the plots and your measurements regularly. coming into field when something is broken, it's changing and correcting the sensors. But what we can do afterwards, when we have all the measurements done, we can do quality control and check certain properties of the data. If they are performing well, the instruments are performing well, or if they are fulfilling the theoretical expectations. For example, for eddy covariance measurements, you want certain turbulence in the atmosphere, so the mixing should be proper. There should be also not too many spikes in the data and a lot of theoretical assumptions that you want to check before actually trusting the half-hourly result and applying it in your analysis. So after you have this quality control done, you can evaluate it, how the outcomes look like, and it can also give you feedback into what to improve next time. Perhaps you find out there is some kind of issue that you could have prevented, so you can just improve your sampling next time. So it's kind of a cycle. Looking into actually applying the quality control, we oftentimes, or the principle is very simple. You create a flag. So for each half-hourly record, you create a flag from 0 to 2. 0 basically means the best quality of data. 1 means it's on the edge, but we are still okay to use that value. And flag 2 means this value should be discarded because there are some flaws that were identified by a certain filter. You can check multiple aspects of the eddy covariance measurements. So you can create multiple filters with the flags and combine them together. So after the flagging, you can combine individual filters together. You can inspect them and then remove the values, therefore apply them. So remove the fluxes. Looking even more into detail, how the combination works. Basically, if you have simple filters, you are just taking maximum over multiple filters. So for example, in the upper left corner, if you look at combination of filter A and B, you just take maximum out of both columns and you create a new column C, which takes all the flags combined together. If you want to apply additive filter, this is something special. This will actually add the value of the additive filter with the maximum value of 2. So actually the flagging system, the flagging scheme can never be higher than 2. So flags are 0, 1, 2, anything else. So here we are adding the value in the filter D to filter C, and you can see the outcome in filter E. The presence of additive filters is a little bit tricky. If you include it, it's actually removing quite a lot of data, but sometimes it's quite useful, especially in the case of flux interdependency. But this is a bit more into details already. So the bottom part is just showing that applying additive filters makes filtering order dependent. So it depends where in the quality control scheme you edit. And it can impact the resulting flags. So in order then to actually summarize the quality control outcome, you can create these kinds of plots using openeddy, where you can see the cumulative effect of individual filters. If you combine them, how the quality actually deteriorates, or actually what's the impact of the filtering on the data. So the last column on the right basically shows you how much available data you have left. In this case, it would be slightly below 70% probably. What openeddy allows you to do also is a quick overview of your data. So you oftentimes want to use eddy covariance results to check for interesting events because it's an observation type of measurement. So in this case, we, for example, notice that there is a certain period where uptake was reduced. So this is in the circle. And we might want to inspect what was happening and perhaps have some deeper analysis of that period. And you can actually see from the openeddy plots that you can generate again rather easily that this is effect of drought. So here, I don't know if you can see my mouse, probably not.
No, we can't.
Thank you. Yeah, I don't know how quickly put on this marker or something, but what you can see is actually that in violet color there is VPD. So it's increasing over days to something like 25 hectopascals, which is already quite high evaporative demand. So the trees are under stress in this case. It's a forest site, and you have limited uptake because of the drought impact. So you can see that during the day 21st of June, there is a precipitation event that's in the middle panel of the second week. So these are 1 week on the top and a second week on the bottom. And you can see that the precipitation event basically interrupted this drought spell, and the uptake is increasing again. So it's just something that you can produce rather easily if you combine your metadata with eddy covariance data into one data frame. You can just use a plot openeddy function and do this kind of visualization rather fast. And so the last part here is that using REDProc, actually you can get full your data set. And after you are done with this, the best person to describe gap filling and flux partitioning would be, of course, Thomas Ladislav, who designed the package. But once you are done with that, you can actually do the aggregation of key variables, plot, for example, net ecosystem productivity, and compare across sites, or you can do using openeddy package this nice windrows that is on the right side. So there is a lot of options then for the aggregation, also using openeddy functions. So on the left, aggregation is done with openeddy, sum function. On the right, it's a package openeddy. So just to conclude, and we have a lot of time to go through the resources, and maybe people also want to try to do some kind of hands-on exercises. I would just like to finalize with this kind of note that it takes a lot of people to actually develop the tools. And when I was starting, there was actually not too much available. And nowadays, it's maybe even more difficult for people to find out which software to use, which is really, really nice thing that we have so many already. A lot of times the software is quite particular, focused on some kind of part of the processing. It's really great that we have these tools because it's quite tough to understand all the parts of the processing chain of requirements data. It's quite rich. And hopefully also with quality control, for example, openeddy is not trying to give you answers to all the issues that exist with eddy covariance data. Basically, if you find out about some useful quality control filter, it would be great to share it and provide it also for the community, and can be implemented within the quality control scheme that you design on your own using just the tools, the infrastructure that openeddy provides. I would also like to advertise the FLUXNET committees. There is ancillary data processing, which is led by Jürgen Knauer, and then open source code development, which is led by lady with surname Misik. I'm sorry, I couldn't remember the first name, but if you look at the Slack, you can see all the links, and it's great to join these kinds of channels because you capture the exchange, you can propose what you are missing, and also learn and ask for questions that you would have about these kinds of topics. In the open source code development, for example, there are advices how to build your own code. So I think great places to exchange. It's also great to discuss their additional products or variables that you would like to have included. So there is already really a lot of tools to compute additional variables out of the existing data. Any suggestions are always welcome. And also, everybody can adapt the workflows that are already available. I will just show you now where you can search for them and adapt them. You can also share them if you would like in the future. I guess we can learn from each other in general. So this is all from me concerning the presentation. I guess I'm still sharing the screen, so I would also like to go through the materials. So on the Slack, I provided the link to my GitHub, where is openeddy package. You can see here installation. If you want to install it in R, is explained at this section. It's actually not yet on CRAN, so you have to follow this guide and download it directly from GitHub, but it's super easy, I would say. If you wanted to find out how to use individual functions and actually what is useful for you out of the openeddy package, if you don't want to use the whole eddy covariance workflow, you can read or go through the openeddy tutorials. I can show you just briefly how it looks like. Here are the sections that are described. You can find out about reading and writing data with units, which I think can be handy for multiple applications. There is remapping of variable names, which is quite useful if you have to fulfill the expectations of different software and different naming strategies. Also for submissions into databases, for example, oftentimes the expected variable names are quite different than what you are storing it in your internal database. Merging data and filling gaps in timestamp. I think this is, again, quite technical, but quite useful. Plotting, I guess this can be handy for a lot of people. These types of plotting where you have multiple variables that are understandable at the same time and visually interesting is not that straightforward to make it robust. So I hope you'll find out that these plotting functions, especially FLUXNet, is quite handy in there. And then considering quality control, there is this flagging and removal of spurious measurements, and the last section, building on eddy-proc aggregation of data. So this is the tutorials where you learn these separate sections, and then you can also go for what we do with our data thoroughly and look into eddy covariance workflow, where basically you get all the parts of the processing chain. You start with data preparation, quality control, continue through gap filling and flux partitioning. Here in this section, basically, we mostly use our eddy-proc package from Thomas Futzler, but the workflow helps you to set settings in the upper section of the code and then run everything very fast and not having to bother with individual functions. And within the summary section, you basically aggregate and summarize your gap filled fluxes and all the meta and other things. So this would be the contribution on my side here. Also, you can check the ROI boundary, which is region of interest boundary. If you measure with eddy covariance, sometimes you have certain expectations. For example, you want to measure agricultural field, you don't want to measure forest, so you want to define your region of interest, which is shown here on the plot. And basically, there is a filter that allows you to filter data that have higher contribution from outside of this region of interest than you would be happy with. So, for example, in this case, in this case, there is 70% contribution that is the requirement to come from your agro field. Another resource I would look a bit deeper, or you probably would be looking a bit deeper into is our eddy software. So again, going to their GitHub, I think you get really nice navigation already. Information about the installation of the package. It's on CRAN already, so you can do it rather easy. And then here is example of some lines of code employing the RDProc software, giving you some very fast results. If you actually want to have a look deeper, there is this place with vignettes. Okay, I just have slow internet connection, sorry. So if you actually click on one of the vignettes, you can check out the description. Sorry, this would be an MD file. And here is basically a web page giving you some nice description of how uncertainty evaluation should be done when you are aggregating daily or annual values. So in vignettes, more descriptions for RDProc. And if we look further to BigLeaf, it's basically on CRAN, but again, there are vignettes here. You can check out some kind of examples and explanations of the application. So maybe I can just show you how it can look like if you set up the openeddy tutorials. So again, going back where you can find it. So if you go to my GitHub, there is a section called openeddy tutorials. Here you could basically check the installation section. You need to download the dataset because the dataset is quite big. It's not stored on GitHub. You download it separately, but then you can download the openeddy tutorials, which is basically here, and put it into the same folder. And then when you open it in RStudio, it looks like this. So if you are in the visual mode, you have everything rendered like a web page, and you can actually press buttons that actually run the code for you. You can also evaluate individual parts of the code line by line. So there is a description how to go about this, and you can go into individual sections. There should be independent. If you notice that they are not, please let me know, and I will try to make sure that the code is improved. You can here navigate in the outline. So if you open this, you are interested, for example, just in plotting, you can just click on the plot section, and you can go through the examples. I was trying to give just the briefest introduction to the functions to give you the most important settings that you could want to change and play with. But always there are suggestions like this with the question mark. If you evaluate this line of code, you will get into the help file. You can see that this is now a help file for FLUXNET from package openeddy. And you can see what are the arguments that you could be changing. And here are explanations how it works and how it can be useful for you in more detail. So I guess this would be all from me for now. I guess we can start with some questions and hopefully also answers.
Okay, thank you very much, Ladia, for that presentation. So we will now take questions if anybody has any questions for Ladia. And you can type your questions in the Q&A or in the chat. Okay, so there's a So, Ladia, there's a question here. While processing a 7 to 9 month data, and if there's a big gap, for example, 2 months in between, what would be the best option to avoid the data that data processing it together or processing it in 2 stages?
Yeah, these are the edge examples. Basically, you would preferably like to avoid these situations. So unfortunately, the help in this case is quite difficult. And I think that Thomas Wutzler actually did quite a lot of work to identify those cases and actually not even allow you to use the tools if the availability of data is quite low. So unfortunately, the tools often rely on a robust and large data set. And if you have really huge gaps and basically just you measure growing season, but you don't have any data, for example, for the winter time, it's obvious you cannot gap fill winter time. So the scripts should be smart enough to basically tell you we cannot proceed because for this period we cannot predict the measurements. But if you have a large gap that is within the similar phenological phase, which is not affecting by some serious management or things like this, you can just try to run all these these two both small chunks together and try to gap fill them to find out if the processing software, this REDProc package, will actually evaluate that it's possible to gap fill for you, or if it would be really too large. But 2 months is already quite a lot, and it's actually also assuming that you have the meteorological variables. So if you don't have any clue about meteorology, it's actually very hard to fill the 2 months gap because you actually don't know what was happening at all. If you already have meteorology, there is at least a chance that you can do something. Of course, there are tools to gap fill metadata with the light. If you have incoming like global radiation, for example, there can be a nearby meteorological station that you can use and things like this. but with large gaps, it's usually quite hard. So there is this quality assurance phase, which is quite important. Also, there are some stations that actually have these movable platforms, and then the research question oftentimes is different. It's oftentimes just really capturing this small set of data, this small period of data, and it's hard to expect that based on a few months of measurements, you can just predict the whole year of fluxes for that particular spot. So then maybe you want to have like a spatial heterogeneity captured rather than the yearly budgets. So yeah, I guess there are unfortunately some limits, and you will have hard times probably to pass them.
Okay. Is there any tutorial available for beginners who want to do footprint analysis? So is there any tutorials that you could point people to if they want to do footprint analysis?
For footprint analysis, I think you can just go through the, I can share again the screen. So if you go to the rolling list of software that we already have the link for in the chat and on Slack, you just go basically to the bottommost part. Oh, not really. Yeah, before auxiliary data processing, here is QN footprint model. And if you go to this online data processing section, it will give you all the necessary information. Basically, if you want to process a footprint for your data set, here is a template of the data that the codes require. So you basically submit something similar to the template. And here is also a description. So you can just download these files that describe how the data should look like. And you can test with the template and obtain some outcomes that look similar to the pictures that you see above. So it basically gives you footprints for different signal percentages. So the outermost circle represents 90% of your signal is coming from this distance. This is a climatology, so it's over longer period of time. Oftentimes, climatologies are footprint climatologies are oftentimes done in, for example, yearly steps. So for 1 year of data, you evaluate what is the typical distance that 90% of your data is coming from. This is usually quite large, so oftentimes the biggest focus is on 80%, 70% footprints.
Okay.
Answers the question.
Yeah, thank you. So another question. Some post-processing packages in our state that they are specialized for CO2 and net ecosystem exchange. But would these packages still be applicable for other gases such as trace gases? So are there software that could do CO2, NEE, and then do other trace gases?
So it's post-processing packages. So it's not concerning the raw data processing. The question seems to be about only the follow-up steps. So maybe we can clarify if Tamrin meant also the raw data processing. But I think this is the case now. The trace gases, other than the basic ones, are actually quite tricky. So defining all those steps that are already available for CO2 fluxes or energy fluxes, it's still also struggle to find out what is the most optimal quality control, for example, for the basic fluxes anyway. So we have already so many years of experience, and it's still hard. So for methane and N2O fluxes, for example, it's even more tricky because the amount of experience is much less people are measuring these fluxes, and also they are much more tricky. Basically, what is nice about NEE and also about energy fluxes is that they are not so much spiky. So half-hourly measurements look kind of smooth if the measurements are typically going well. Of course, there can be some kind of outlying values that are reasonable because there was some change of mixing or things like this. But with methane data, the fluxes, the spikes are much more common. And then defining the proper gap filling, proper quality control is much more difficult. And I guess this is still work that needs to be done to kind of standardize and put the software out there that is doing these things. For the methane fluxes, oftentimes people stick with neural networks. And because these oftentimes are packages that have general application, you would probably mostly check for papers that describe like different attempts to gap fill methane fluxes using different packages. They would oftentimes probably describe what kind of variables they were using for these particular gap filling strategies that were applied. And for quality control, I got also this question before, what can we do about methane and N2O quality control with openeddy, for example. There are certain characteristics that are extracted from raw data using eddy Pro raw data processing software that you can utilize in quality control, but actually it's not much tested. So what are the outcomes and how much efficient these quality control steps would be. So we still need more data and more checking, I guess, to find out how to go about it. It's more difficult, yeah.
Okay. Hamilton, do you have a question? I can see your hand. Your hand is up.
Hello. Oh no,
Yes.
I was just saying. I was just trying to clap to say thank you for asking the question about the other packages for trace gases.
Okay.
Yeah, thank you for the question. I guess it will be more and more common to ask for these, and then at some point somebody will develop something more like user-friendly. I guess so far it's still not so straightforward, but I guess it's really always a good thing to get in touch with people that are dealing with, for example, methane fluxes if you want to do processing steps for these and ask what they are doing, because I guess could be the easiest to build on the experience of scientists that already publish. Some tools might not be shared openly. Yeah, just good to exchange with people.
Okay. So Ariana is asking if you could share the FFP link.
Sure. Yeah, we can do it just separately like this. I hope it should be. Just check that it. Yeah.
And we have another question. Would these packages be relevant for CO fluxes in relation to the previous question about whether we can use the software for other fluxes beyond CO2?
Yeah, I mean, there are like certain differences. Nowadays, you can do really amazing things. Yeah, so actually the amount of analyzers and possibilities is really extending. So you can do also ozone fluxes, and you can do VOCs, so volatile organic compounds. So nowadays you can have a detector that actually measures concentration in high frequency of like 100 substances at the same time. So it's incredible on one side. On the other hand, it's really difficult to actually manage all this data and do the data processing efficiently and fast. So oftentimes these machines then come with kind of software packages built by some research group that try to implement it for the first time and things like that. With methane, for example, we have some instruments that are provided from Lycor that already go into the processing using eddy Pro really fast and easy. If you again have some kind of different methane analyzer, you can again plug it for sure into eddy Pro and compute the values. It just requires certain also technicalities when you want to align the sonic anemometer with the concentration measurements for these to be synchronized properly, and all of this oftentimes then you need to assure yourself. If this quality assurance is not done properly, can be very tricky to process the raw data and even then to extract some kind of sensible outcomes in the post-processing. But definitely for these kinds of gases like COS or CO, I think there is no like agreement within the community because there is so few people measuring these fluxes that it's hard to give clear suggestions what to do. I just know that for COS there should be people from University of Helsinki like Ivan Mamarela and colleagues from Finland that are dealing. So probably the best case in these cases, working with very specific types of fluxes, is to contact the experts that are dealing with just these and ask if they have some suggestions. But having a robust code that would be working for all the types of fluxes and their specifics is hard to expect.
All right, thank you. Do we have any more questions? So you can also unmute yourself and then ask a question. I just want to quickly say that the meeting is being recorded, so and we will share the recordings with you after we've put all of them together. There's one more question for you, Ladislav. Is there some R package available that makes eddy Pro output suitable for openeddy, like takes what's needed from eddy Pro output and makes it like this openeddy sample file that you shared?
So thanks for the question. It's actually quite easy to answer this. Basically, if you go into EC workflow on my GitHub, you can see that there is one of the workflows, number 1. So there are 4 workflows, all are aligned. So in the first step, basically, you have this data preparation phase. And here in the first description, it basically gives you the main motivation, which is to take data from eddy Pro and from your meteorological database, probably, and put them together. So actually, eddy Pro output is taken as is, almost. There are just very few things needed to do, like, for example, translate the timestamp into daytime information and things like that. But otherwise, all the column names and everything is kept the same. we just have to make sure that the metadata are understandable also then for openeddy. And once you are finished with all the steps within openeddy, concerning basically the quality control, then the output is aligned with eddy-proc. So you are in the beginning, you are taking the output of eddy-proc as is. You are applying all the quality control within openeddy using the naming strategy of eddy-proc, and then you are translating it so the eddy-proc understands what it is dealing with. So this is probably answer to Mikhail's question.
Yeah. Any more questions for
I think
Ladi?
there is one from Tamrin again. Out of curiosity, is there anyone else here measuring fluxes of trace gases or using separate gas measurement instrument paired with sonic?
I think this is more general to everybody in the group.
Yeah, basically, my colleagues, Natalia Kowalska, that you heard yesterday, and Georg Jocher, who was not giving a talk, but is part of our group. They basically measure methane fluxes in floodplain forest, and it's done using iodine instrument paired with sonic anemometer. And they just log it independently on the like basic setup. So definitely they would know also some kind of information, but I think there is a lot of teams to ask. So yeah, I don't know if there is anybody else in the community that we gathered today. That's a good question to ask around. Anybody having experience with that? Yeah, so we have, I don't know if I'm reading the name properly, answer from Phoebe. There's also some experience there. We have actually a colleague who is measuring these ozone fluxes and VOCs. So it's possible to direct you if you are interested. Just send me a message that you would like to connect with those people. But really, if you have some papers in mind concerning with the type of measurements you are dealing with, oftentimes it could be a good idea just to contact those scientists.
All right. If we don't have any more questions, then I think we can say thank you very much to you, Ladia, for an interesting talk. And
thank you.
And thank you very much to everybody who made time to join us today. This has been the second day of a 3-day workshop. Each day we are starting at 10 a.m. UTC to 12. And we have different speakers talking about different aspects of eddy covariance measurements and processing. So yesterday we talked about how to basically the basic ideas about eddy covariance method and measurements. And today we've seen how to process some of that data. Tomorrow, again, we continue with Pascal talking about how to set up and run a site, and also using an example from some of his field work that he's been doing around the world. So we hope to see you all again tomorrow for the final day in the series of workshops that we've been holding. Again, I just want to remind you that we can continue the discussions on Slack. So there's a Slack channel that we shared with you through the emails. Please join us on Slack and let's continue the collaborations and the discussions going forward. So thank you very much, and we hope to see you again tomorrow.
Thank you very much.